Greetings, fellow truth seekers, and welcome to Paper Ledge. I'm Ernis, your guide to the latest discoveries bubbling up from the research world. Today, we're venturing into the intricate world of medical imaging. Buckle up, because we're about to dissect a fascinating paper titled MedReason-R1, Learning to Reason for CT Diagnosis with Reinforcement Learning and Local Zoom. Now, imagine you're a cosmic physician, floating through a galaxy of CT scans. Each scan is a planet, swirling with mysteries. Our mission? To develop a sharper lens, a more intuitive understanding to diagnose diseases with unprecedented accuracy. The challenge? Existing AI models, even the really fancy ones, still struggle with the nuanced art of medical image interpretation. Yeah, turns out reading a CT scan isn't quite as easy as identifying cats on the internet. So, what did these clever researchers do? Well, they've built a better telescope, metaphorically speaking. They've created a new AI model called MedReason-R1. And it's a triple threat. It tackles three key problems: the lack of good training data, the difficulty in spotting subtle disease features, and the absence of clear, logical reasoning in the AI's decision-making. Let's explore how they do it, step by step. First, let's check out the data issue, or more specifically, the creation of a new dataset. It's called CT. Think of it as a massive cosmic atlas of CT scans. This dataset contains over question-answer pairs related to CT scans. That's a lot of data. But simply having more data isn't enough, right? You need a way to focus the AI's attention. That's where the SECOND clever trick comes in. The local zoom in patch augmentation. Imagine a doctor magnifying a specific area of a scan. These researchers mimic this process by embedding a zoomed-in patch of the lesion right there in the corner of the image. It's like giving the AI a cheat sheet highlighting exactly where to look. But hey, if it works, it works. And the result is to help the AI focus on fine-grained details while still understanding the overall context. Now, let's waltz into the third room of our memory palace. This is where things get really interesting. Reinforcement learning with something called GRPO, or Group Relative Policy Optimization. Okay, that sounds complicated, but stick with me. Remember how we want the AI to not just identify diseases, but also to explain its reasoning? Well, GRPO helps incentivize the AI to think step by step, rewarding it for structured, medically sound explanations. It's like teaching a toddler to explain their thought process. Only this toddler is a super-powered AI analyzing CT scans. So, what were the results of all this cosmic engineering? MedReason-R1 absolutely crushed it. It outperformed existing general-purpose and medical AI models on chest CT abnormality diagnosis. And not only did it get the right answers more often, it was also better at explaining its reasoning. It's like the AI finally learned how to think like a doctor. But that's not all. The researchers also tested their model on general image understanding tasks, and it held its own. This means that MedReason-R1 isn't just a one-trick pony. It's a versatile tool with potential applications far beyond medical imaging. Now, I know what you might be thinking. Okay, Ernie, this all sounds great, but what's the big deal? Well, imagine a future where AI can assist doctors in diagnosing diseases with unparalleled speed and accuracy. Imagine fewer missed diagnoses, faster treatment, and ultimately, healthier lives for everyone. That's the promise of MedReason-R1. It's a step towards a future where AI and humans work together to unlock the mysteries of the human body and conquer disease. So, keep exploring, keep questioning, and keep pushing the boundaries of what's possible. Until next time, this is Ernie, signing off from Paper Ledge.